The next gas law we're going to discuss is Charles' law. And Charles' law deals with volume and temperature. So let's say we've got a balloon at 0 degrees Celsius. Then you're going to warm up the balloon to 20 degrees Celsius. What's going to happen is the balloon's going to expand. And if you keep heating up the balloon, eventually it'll pop. The reason for this is Charles' law. What this says is that as temperature increases, volume is also going to increase. Think about the kinetic energy of the particles. As the temperature increases, the particles are going to move around a lot more. There's going to be more collisions with the sides of the container, which is going to increase the container. So as temperature increases, volume is also going to increase. Now, we know for Charles' law, we've got two things that are going to be constant. They're going to stay the same. Pressure is going to stay constant. It's not going to change. And the number of gas particles is also going to stay constant. It's not going to change either. Now, the equation we want to know for Charles' law is going to be V1 divided by T1 is equal to V2 divided by T2. That means the volume of 1 divided by the temperature of 1 is equal to the volume of another gas divided by the temperature of another gas. So again, for Charles' law, we always want to know V1 over T1 is equal to V2 over T2. Now looking this on a graph, what this says is pretty straightforward. As temperature increases, volume is also going to increase. And as temperature decreases, volume is also going to decrease. We call this a direct relationship, meaning that as one variable increases, the other variable is also going to increase. The last thing we want to know is when we're solving problems for Charles' law, temperatures must always be in Kelvin. This is very important. If you don't use Kelvin in the equation, you'll always get the problem wrong. And this will be my expression if I see people who know how to solve the problems making simple mistakes because they forget to convert to Kelvin. So, don't forget, always convert to Kelvin. Let's take a look at how we would solve a sample problem. The first step is just to read the problem. So we've got the temperature of a 0.65 liter sample is 580 degrees Kelvin. They're saying if pressure remains constant, what's going to be the new volume as temperature increases to 1300 degrees Kelvin? So our next step is to label the numbers as pressure, volume, or temperature. Our starting 0.65, that's going to be our starting volume, so that's going to be V1. Our starting temperature is going to be T1, 580 Kelvin. Our ending temperature is going to be T2, that's 1300 Kelvin. And what we're solving for is going to be volume 2, the volume at the end. So our last step is to plug these numbers into our equation. And our equation is V1 over T1 equals V2 over T2. So plug in the numbers, 0.65 divided by 580 is equal to volume 2 divided by 1300 Kelvin. Now the way that we solve this has to do with cross multiplication. That means we're going to multiply the top and the bottom by each other. So let's take a look at how we would solve this. Our first step in cross multiplication is to multiply 580 times V2. So on one side we've got 580 times volume 2. On the other side we're going to multiply 0.65 times 1300. So we've got 0.65 times 1300 is equal to 580 times volume 2. Our last step is to solve for volume 2. Multiply this together, divide by 580, and we end up with volume 2 is equal to 1.5 liters. Our last step is to say, does this make sense? We know that as temperature increases, volume increases. So in this case, the temperature increases. So that means our volume should increase as well. And we can check. It does. 0.65 increases to 1.5 liters. This makes sense. We can go with this as our final answer. Now our next sample problem, we've got a balloon has a volume of 5.6 liters and a temperature of 98 degrees Celsius. If the volume increases to 9.5 liters, what's going to be the temperature of the gas in Celsius? Now, we read the problem, we want to label the numbers as pressure, volume, or temperature. So 5.6 is our starting volume. That's going to be V1. 98 degrees Celsius is going to be our starting temperature. That's T1. 9.5 is our final volume, so that's going to be V2. And that means we're solving for T2. So we want to plug into the correct equation. Hopefully you've noticed something that we need to do with this problem. And that's, we're given our temperature in Celsius, but we need to make sure we're using Kelvin in a problem. So we've got our equation V1 over T1 equals V2 over T2. First off, we want to get our answer in Kelvin. So we, to convert from Celsius to Kelvin, you add 273. So 98 plus 273 gives us 371 Kelvin. Is going to be our temperature 1. Plug in the numbers. 5.6 divided by 371 is equal to 9.5 divided by temperature 2. We want to cross multiply to solve this problem. So first step, cross multiply 5.6 times T2 gives us 5.6 times T2 is equal to 371 times 9.5. We want to solve for temperature 2, meaning we multiply these numbers together, divide by 5.6, and we end up with temperature 2 is equal to 629 Kelvin. Last but not least, we want to say, does our answer, first off, it needs to be in Celsius. So we want to convert back to Celsius. Subtract 273 degrees, which gives us 356 degrees Celsius, very, very hot. Now let's see if this makes sense. We started off with 98 degrees Celsius, we finished with 356 degrees Celsius. We know that as temperature increases, volume should also increase. So in this case, if volume increases, that means temperature should also increase, and it did. Our answer makes sense, and we can go with this as the end of our problem. So yes, it makes sense, and yes, we know how to solve problems involving Charles' law.